Hello everyone, today we're focusing on the topic of number and the subtopic set language and absolute value under Cambridge IGCSE Mathematics. So we're starting off with the notation of Venn diagrams. So when you use Venn diagrams and set notation in general, you have to be very familiar with the following symbols. So we're going to go through one by one. The first one is basically a U. And it is representing union. So if you want to say A or B, it's a bit like saying A union B. So if you want to shade that in a particular Venn diagram, as you can see, that is basically everything inside the two circles of A and B. So everything that is inside circle A and circle B and in the middle as well. Then we have A intersection B, which is basically an upside down U. So you can remember U for union and intersection, there's an N. So you can represent that with this upside down U. So intersection is like it sounds. Basically, we talk about the overlap between the two circles. So in this case, that is shaded in green there, the overlap in the center. Moving to the next one, subset. So subset is like when you have a big set. In this case, the big set is B, and then we have a smaller set inside of B. In this case, that is A, and we represent that with a side long U like this, okay? So basically, A is a smaller set inside of the bigger set B. Next, we have the element symbol or the member symbol. So basically, it's a bit similar to the euro sign. It's like an E with a line through it. And what we use this for is to say that a particular letter or a particular number is within this set. So for example, we know that A is inside of the set X. So therefore, A is a member of X. Similarly, B is also a member of X, so is C and D. The next one is complement. Complement is denoted basically with the use of an apostrophe sign. So whatever set you're talking about, you can write the letter. So if it's set A, it's A with an apostrophe. If it's set B, it's B with an apostrophe. And what this basically means is not of A. So everything outside of set A should be not of A or complement of A. So that's why you can see that in green we have shaded everything outside of the white circle. And the next symbol we have is universal set. It's often denoted by a very curly looking symbol like this. It's a E of some sort. And what this basically means is the universal set, right? And this universal set is everything inside of the Venn diagram. That's basically what it means. So if you want to write for this particular one, the universal set, you can see that A, B, C, D, E, and F are all inside the square. So therefore, they're all elements inside the universal set. And that's how we denote that in set notation. Moving on, the next one is the number of. So if you want to express how many elements are there in a particular set, then you use the n of A or n of B, depending on which set we're talking about. So here, since we're talking about set A, so the number of elements in set A, you can count 1, 2, 3, 4 letters. So therefore, n of A is equal to 4. And finally, you can see on the side, we have the basic notation there. So empty set or null set, we call it, is often denoted with 0 with a line through it. Or sometimes you can just write the two brackets with nothing written in the middle of it, okay? So usually we denote sets like this. For example, we can have a set which has 1, 2, 3, and we write that with a curly bracket to show that these are the elements inside the set. Or you can use the other notation that we have here where they have set A is equal to curly bracket X such that, so those that dot there or the colon there is basically X such that X is an integer between 2 and 9, including 2 and 9, because we can see that the inclusive symbol is there as well. So following that, we can write down exactly the elements that should be in set A, and we can see that that is 2, 3, 4, 5, 6, 7, 8, and 9, because 2 and 9 have to be including. And finally, to finish off with a bit of absolute value knowledge. So basically, absolute value is the non-negative value of a number, right? So if you put the symbol like this, 2 straight lines around the number, that just means take the positive value of the number that you have written in between it. So positive value of 5 is simply 5, but positive value of negative 5 is 5. And that's basically it for today's session. So, all right, time to practice a few questions. So we're going to start off with this one. Solve 3 minus 8. So that's going to be negative 5. Modulus is the name given to the lines here. So 4 take away 7 is going to be negative 3. And with the use of the modulus, we're going to remove the negatives in front of the 5 and 3, which leaves us with an answer of 5 times 3, 15. So we're going to go for 15 for this one. All right, next one. A basically is a set with the letters of education. B is filled with the letters of the set which is mathematics. And we have list the members of the set A intersection B. So basically we're looking at which of these letters overlap in both the sets. So we can see that E is present in both the sets. We can also see A, and we can see T. I2 is there. And I think, what else do we have? Oh, we have C, right? Education has a C. Mathematics has a C as well. So therefore, we're going to go with option number 3. Moving on, put these values in order from smallest to largest, okay? So the first one basically simplifies to negative 6. The second one simplifies to 3.5. The third one to 2.7. The fourth one to negative 1.5. The fifth one goes to negative 4. And the sixth one goes to 5. So putting these in order, we can see that negative 6 is the smallest, right? So that's number 1. The next would be the 4, then the negative 1.5, and then 2.7, 3.5, and 5 going last. So if we see which of these we have to go for in order for this to be true, it has to be option number 3. Okay, and then another one with putting these values in order from smallest to largest. So again, let's just jot that down. So this is going to be 9. This is going to remain as negative 1.4. This is going to become positive 3.6. Again, negative 4.5 will remain the same. 3.2 remains the same. And 2.8 does not change when the modulus is applied. So looking at it, if we have to put the order of position, so negative 4.5 is the lowest, and we can see there's only one option which goes there, but you can always double check. The next thing should be negative 1.4. Yep, that seems correct. And then 2.8, 3.2, 3.6, and finally 9 being the biggest. So that's right. So we're going to go with option 4 for this one. And finally, solve negative 2, negative 10. So that's basically negative 12 modulus divided by 3, which is the same as saying positive 12 divided by 3. So my answer here is going to be 4. And that brings us to the end of session number 2. Hope you guys are really enjoying my lessons, and I can't wait to catch you with the next one.